This is our scientist friend Travis. He likes to climb and he studies the evolution of climbing animals like geckos. Geckos have special toe pads that are covered in microscopic hairs. Each tiny hair sticks very weakly to a surface, but there are so many of them that together they make enough force to stick to a wall, or even upside down. Scientist Karina also likes to climb, so she met with Travis to see if she can learn some tips from the geckos.
So you're saying that if I had gecko hands, climbing would be easier?
Yeah, so if you had all the microstructures that geckos and anoles and other lizards with adhesive toe pads have, then you could totally climb walls like a gecko. The problem would be you would need really, really large fingertips and toes.
Like how big?
Like the size of a piece of notebook paper.
Each finger and toe? Oh my gosh, so why?
So scaling walls is all about scaling body size. So large and small animals have toe pad sizes that are adapted to their body sizes. And this is true across all animals with toe pads. Insects, other arthropods, reptiles, amphibians, and mammals.
Okay. Wait, what kind of mammals have toe pads?
Bats. So some bats have suction cups on either their elbows or their wrists.
Whoa. So how do you measure toe pad size?
So I actually brought a live gecko to show you that today. So this is Wallace. He's a crested gecko from New Caledonia. And so this is a custom 3D printed setup to hold a camera with some bars to control how close the camera is to a vertical piece of glass. And we've got a little scale bar attached there. So we can actually take a live gecko and let him climb up the glass and hold him so that his toe is right in front of the camera and take a picture. And then we can use computer software to take measurements from the photograph.
When you say scaling, you mean how size and shape of animals change when comparing big and small species? And so basically, a bigger gecko needs bigger toe pads because it's heavier.
Mm-hmm. When we compare the mass of big and small animals and the surface area of big and small animals, the difference in mass is a lot more than the difference in surface area. If we imagine a tomato and a pumpkin, the tomato, let's say, is 7 centimeters across, and the pumpkin is 21 centimeters across. We can see that the pumpkin's 3 times larger. Assuming these are both spheres, and we can use some really simple math and calculate surface area and volume. And then if we assume they're filled with water, we can calculate mass. If we imagine the skin, the surface area covering the outside is 154 centimeters squared and 1380 centimeters squared, which is a difference of 9 times. And then given they're filled with water, our little tomato would weigh 180 grams and our pumpkin would weigh almost 5,000 grams for a difference of 27 times. We can see that the pumpkin is 3 times wider, but it requires 9 times more surface area, 9 times more skin to cover the outside of it, and it actually weighs 27 times more. So if you imagine this is 2 different animals of different sizes, their mass has gone up 27 times, but their skin or their surface area, which here would be the size of their toe pads, has only gone up 9 times, which can create a problem for big animals. So this leaves us with a question: do larger animals have disproportionately larger toe pads to deal with their large body masses?
In other words, maybe it's not just the equipment you have, it's size that matters.